I know this is kind of your first video with me, so bear with me a little bit, but I hope you are having a wonderful day. We are going to be on page 108 for our notes today. And this video is just in case you need a refresher, or if you missed the Zoom call, then you can get the notes of me talking just like normal. So we've been talking about finding proportional relationships and finding out if something's proportional. And today we're going to be able to write equations of a proportional relationship. Okay, so we have a sponge as an example of a filter feeder. It takes in food by filtering water through its body. The sponge maintains a constant flow of water through its body. So again, constant, that means it's proportional. Okay, what is an equation that represents the proportional relationship between the time and the amount of water filtered? Okay, so it says in 10 hours we do 8 liters, in 15 hours we do 12 liters. Okay, so we have our little chart here that they've made us. And we have what's called the constant of proportionality, which a lot of times students refer to as the COP, okay? And that's the constant multiple that relates the proportional quantities X and Y. So remember how yesterday we were finding that number to decide if it's proportional or not? That's the constant of proportionality, or the COP, okay? And remember how I was telling we use Y over X? This is where it comes in, okay? Now the COP, or the constant proportionality, is represented by the letter K. Why they chose K, it just is what it is. Sometimes math isn't always super logical, but the constant of proportionality stands for K, all right? So if we're looking at our table here, we know in X hours we get 8 liters, in 15 hours we get 12 liters, okay? I want to first decide that they're proportional. So again, we're going to do Y over X. Remember I told you that was important yesterday? So 8 over 10 gives us 0.8, and 12 over 15 also gives us 0.8, okay? Now, if you accidentally flip those numbers, you'll get the same number both times, but the actual constant proportionality will be different, okay? So our constant proportionality K is 0.8 because that's what's the same every time, okay? Now, the reason it's Y over X is because we have this formula, okay? And this is the one we use the most. Y equals K times X, okay? And K is always going to be some number. It might be a whole number, it might be a decimal, it might be a negative number, right? But it's in the math world, we like when things are Y equals, okay? So that's why when we solve for K, which is what they did up here, they said, well, if I divide both sides by X, that solves for K. That's the constant of proportionality, right? So that's why it's Y over X every time, okay? So again, you can use the equation in the form of Y equals KX, or Y equals the COP times X, to represent any proportional relationship, okay? And so in this case, our equation would be Y equals 0.8X, because our constant of proportionality is 0.8. So once we find that COP, or constant of proportionality, we just plug it in for K. All right, and that's our equation, and then we're done, because you guys haven't learned how to do anything with two variables yet. So we're just writing the equation, okay? So let's practice this again, okay? So Maria made 2 batches of fruit punch. The table at the right shows how many quarts of juice she used for each batch. Write an equation that relates the proportional quantities, okay? So again, we have X in the first column, and we have Y in the second column. That's true, I'd say 99% of the time. X will be in the left, Y will be on the right. Occasionally they do some weird things to flip you around, but for the most part, X is on the left, Y is on the right. So again, we're doing Y over X, right? So we're going to do 8 over 5. And if I type that in the calculator, I'm going to get 1.6. And if we do 16 divided by 10, again, also 1.6. So our constant of proportionality is 1.6, as long as we do Y over X. So the equation then that represents this proportional relationship is Y equals 1.6X. So our convince me here is, how does the equation change if the amount of grape juice is the independent variable X and the amount of apple juice is the dependent Y? So what that would mean is our fraction would flip, right? So if we changed the apple juice to be the Y value and the grape juice to be the X value, all that would change would be the constant of proportionality, right? So that would change to 0.625X instead, okay? So as long as we know what the X and Y are and we determine that, we're all good to go, okay? So we're going to go ahead and flip to the next page here. So in example 2, it says solve problems using equations. So we know that 1 inch is equal to 2.54 centimeters. How many centimeters long is an 18-inch ruler? Okay. Now what's nice about the constant of proportionality is what that means is it's worth for one thing, whatever thing we're doing. Okay. So in this case, it's 1 inch is 2.54 centimeters. So 2.54 is our constant of proportionality, or our multiple, okay? So that's why they're replacing K with 2.54 here. So our equation is going to be Y equals 2.54X, okay? Now, x is the number of inches, okay? So if we're trying to find the number of inches, or I'm sorry, the number of centimeters for an 18-inch ruler, I would do 18 times 2.54. Now, some of you might have been like, Miss Oz, I could have done that without an equation, and that's fine, right? But I'm showing you where this stuff is coming from, so that way if you ever get stuck and you're like, I don't know if I multiply, I don't know if I divide, you can use your equation to do that, right? So if we plug in 18 for x, we'd have 2.54 times 18, which if we type in a calculator is 45.72. So the ruler is 45.72 centimeters long, okay? All right. So let's go ahead and go on to the try it here. So a florist sells a dozen roses. So again, we have a dozen, which remember means 12, for $35.40. She sells individual roses for the same unit cost. Write an equation to represent the relationship between the number of roses, x, and the total number of roses, y. So again, remember our COP is y over x. Well, y in this case is roses. I'm sorry, the cost of roses, I apologize. Cost of roses over the number of roses, because that's our y of x value, okay? So the cost in this case is 35.40, and our number is 12. So if we do 35.4 divided by 12, so this is going to be 2.95. So that is our constant of proportionality, or our k value. So our equation is going to be y equals 2.95x, okay? And I'm going to get rid of this little picture here so that way I can have some more room. Okay, now that's our first question, was write an equation to represent the relationship. Now how much do 18 roses cost? Well, I'm going to plug 18 into my equation. So I'd have y equals 2.95 times 18. And like I said, some of you will be able to piece this in together and be like, okay, Miss Oz, I knew that I need to find what one rose costs, so I did 35.4 divided by 12. Now I have 18. I multiply that by 18. That's fabulous, right? And I applaud you if you can do that. But again, this is so that way if you get to a problem and you're not sure how to do it, you can use these skills to help you. Okay? So if I do 2.95 times 18, I get $53.10 for 18 roses. Okay? You also could have set up a fraction proportion like we did the other day, where you did 35.4 over 12 would equal x over 18, right? That also would work. Okay? All right. So example number 3, we're going to determine whether y equals kx and describes the situation. So can you represent the total cost y for admission and x rides at an amusement park using an equation in the form y equals kx? Explain. So if I'm looking at this, we're going to make a table that shows the cost. So 1 ride is $25, 2 rides is $30, 3 rides is $35. Again, I need to see if this is proportional, so I'm going to do y over x. So again, this is my x column, this is my y column. Well, 25 over 1, 25. 30 over 2 is 15. Ooh, that doesn't work. 35 over 3 is $11.67. This is not proportional, right? Okay, so therefore, if it's not proportional, I cannot write an equation for this, okay? Oh, and by the way, they're getting those numbers from the little thing that I erased with the fun fair, okay? All right. So let's go ahead and look at the try it down here. So we have balloon A is released 5 feet above the ground, and balloon B is released at ground level. Both balloons rise at a constant rate. Which situation can you represent using an equation in the form of y equals kx, okay? Now, if we're looking at this, we want to know to see if it's proportional, right? So 9 divided by 1 is 9. 13 divided by 2, 13 divided by 2 is going to be 6.5, right? This is not proportional for balloon A, okay? So if you need to write that, you can. So 9 over 1 does not equal 13 over 2. But if I do that for that second one, 4 over 1, that does equal 8 over 2. Whoops, that was a bad 8. Sorry about that. Which equals 12 over 3, right? They all equal 4 over 1. So balloon B, we could write as an equation because the constant of proportionality is 4, because it reduces to 4 every time. So this equation, in fact, would be y equals 4x for balloon B. Okay? So again, if it's not in proportion, we can't write the equation. Also, as a little hint, if there's any adding or subtracting in the equation, it is not a proportion. It's not proportional, okay? Because we have that plus, okay? So a proportion equation will always have y equals some number times x. There won't be a plus 1 or a minus 5 at the end. As soon as you see adding or subtracting, not a direct proportion equation, okay? I hope this video finds you well, and we'll talk to you later. Bye.